Hey, Ivan, welcome, man.
Glad to be here.
Yeah, I haven't spoken to you in a couple of weeks, so we're doing another one of these sessions.
Yep.
Last time we spoke, we covered the basics of CubeSats. You educated me on what they are. What they could be potentially used for. How it's aligned with your vision of enabling more exploration across the solar system.
Yep, definitely.
And today you've shared something else with me. I haven't had a chance to go through the entire article like I was sharing with you. We just decided to do this pretty much in the past 30 minutes or so.
Yeah.
I was out grocery shopping, but so I'm going to pass it to you and what's going on in the CubeSat end, and what is Apophis, and let's talk more about this.
Yeah. Well, the article is not special. It's just talking about a bunch of missions the UAE and Canada has planned, and how, Canadian companies should be more involved in space. I'm neither Canadian, I do not reside in it. But the article does mention something about the Apophis asteroid, which is an asteroid that back in 2004 was predicted to hit Earth.
Oh, wow.
But, more accurate, because of the trajectory it was coming in at, but more accurate calculations by NASA and stuff, they've determined that it's going to pass in April 13, 2019 at an altitude of 40,000 kilometers, which is about the range of a geocentric satellite.
Okay.
So will pass within a reachable distance for many missions, especially in a 9-year period left. People have been planning this mission since like back in 2004. Many people have trying to figure out, missions they can plan, studies they can do, because this is one of the closest asteroid. It's about 340 meters in diameter, and it weighs, I believe, 40 tons. I need to look up the weight on that. 40 billion tons, not 40 tons, sorry. 40 billion tons, yeah. So it's a sizable chunk of asteroid that's passing relatively close to Earth. And it's going to have two passes, one in 2029, another one in somewhere around 2034 or 35. And so both of these passes is like a unique opportunity, one going and coming back. So it's making an elliptics. But to us, it's 2 points that's intersecting us that we can get to at a reasonable price and cost. And so CubeSats would be great because we can have multiple devices which, dedicated instruments, some that can actually attach itself to the asteroid while others observe it from around. Maybe some can, adjust itself trajectory to follow the asteroid in its wake. It can, get data from its trails and stuff. So there's going to be a lot of missions that people are planning because of the close relativity. And, for everyone from Russia, US, I'm sure, like, NASA, Canadian Space Agency, UAE, the new Australian Space Agency, I'm sure everybody's planning missions to this, because there's still plenty of time. There's going to be a lot of technology advances from now and then. So, we can use all that to, get as much data out of it. And this can be like a stepping stone to eventually mining asteroids in the belt and stuff.
Okay, so sorry, when is the first flyby? I understand is the elliptical, so it's going to do 2 flybys, one coming in, and whatever the orbit happens to be is going to kind of go like this, loop around because of the gravity of Earth, I'm assuming, is going to bend back.
It's its own orbit. It has little to do with Earth's. It does have something to do with the Earth's gravity and Earth's mass, but it also has its own trajectory. So it will. You'd have to just look at the picture of how it's going to pass to get a better understanding of it. But on April 13, 2029, the first pass.
Okay, so 9 years from now.
Yeah.
Less than 9 years.
Yep. So it's a running time clock. Some people have been working on this for 10 years. I'm starting off, somewhere in halfway point, and just trying to figure out where, what kind of satellites I should build, what kind of equipment it should have. This is like a long-term mission, adding on to more commercial stuff in the shorter term.
Yeah. So
Yeah.
is this like 99942 Apophis, Apophis, or just Apophis?
Yes.
Yeah, okay.
Yes, that is the one.
So 99942 Apophis is what we're
Yes.
talking about. Just so like anyone kind of tuning in, for the context of somebody who may be tuning in right now, and that would be the, well, I'll plug in the link to the article you shared with me, which is from a Canadian website. But I think also we'll plug in the link to the Wikipedia page for
Yeah.
99942. Sorry, 99942 Apophis. I wonder what Apophis means. Sounds like a Greek kind of a name.
I don't know. I mean, whoever like found it gets to name it. So
Right. So what was the, yeah, I guess so. So what was the recent ESA lander to the comet? That was Rosetta's been in existence for a while. Was that Rosetta again that did the, like, it actually landed on the comet, and that was like
was that was that ESA or JSA? Honestly, I remember like reading about it, but it's been a
I'm
while.
pretty
It's
sure it was
slipped past my
ESA.
mind.
Let me, I'm on the, yeah, it's 27th of July 2016.
Okay.
No, hold on. Yeah, September 30th, 2016, the Rosetta spacecraft ended its mission by hard landing on the comet in the Ma'at region. I don't know what that means. The Ma'at sounds like, anyways, so yeah, that's the most kind of recent project that I can think of in terms of, like, actually landing something on a comet. So in this case, what the probe that, the thing that was flying all this time and what ESA landed was on a comet. But so is Apophis 99942, is it a comet, or
Yeah,
is it,
it
oh,
is a
it's still a
comet.
comet?
Yeah.
I'm kind of like I was trying to like figure
Well,
out
it's an asteroid. Sorry, it's an asteroid. Yeah.
it is an asteroid. That's what I was,
Yeah. It is. Yeah. Sorry, it is an asteroid. Yeah.
okay. So I'm just trying to classify how big of a threat this could be.
Oh, it's not. It's been long ruled out. It's not a threat. It's just close enough for the scientific community to study it better. I mean, honestly, like it would be really cool if we can, study it on its first pass and try to figure out, some kind of mechanism to try to alter its trajectory as an experiment. But that kind of like that would be a really cool thing to do. But the kind of budget it requires is humongous.
Yeah, but hold on. The Okay, so like the Chicxulub, I think that's how it's called. The one that wiped out the dinosaur, which happened a long time ago, obviously
Yeah.
66 million years ago, was 7 to 50 miles in diameter, and it's 10 to the power 15th. It's like a range that they've given on Wikipedia. Whereas, so that was actually pretty huge. Whereas
Yeah.
Apophis looks like it's around like the size of, I'm on the Wikipedia page. It's, I don't know if I can share this. Maybe I can.
It's about 340 meters. Yeah. It's about
Right.
1,100 feet.
Right. Let me actually put this on the, well, I'll just put this just for the sake of whoever may be tuning in. I'll just, how do you share screen? Is it still going to be recording if I share it?
Yes.
Okay. So I'll just share it right now. Can you see my screen?
Yeah.
Okay. So this was the actual asteroid that wiped out the dinosaurs. Yeah, so 7 to 50 miles would mean it's pretty big. Like it's from, like, you live in New York, but in Toronto
Yeah.
terms, it would be like from here to Guelph, Ontario, which is quite a ways. Like it takes me 45 minutes driving on the highway to get there.
Yeah.
Maybe even beyond that, because 50 miles equals like almost like 90, 100 kilometers, I think.
Yeah.
Now, when we switch to Apophis is like about this big. So I can appreciate, even like from an uneducated perspective, this is like the size of, looks like Empire State Building. Even if it was coming really fast and like on a trajectory that could cause damage, I want, like, it doesn't look like it's a species-ending asteroid. Maybe it will take
Eh,
out half the city if it did fall
eh,
on a city.
It'll be catastrophic, man. Like the world is so interconnected. Even small causes can have huge impacts. I mean, it won't like wipe out the entire human civilization, but it can be dangerous if something like that hit.
Right, right,
But
right.
you also have to account for the entry distant angles and stuff, how much it burns up,
For
how
sure.
much it enters. Probably won't be much left by the time if it did enter.
Yeah, for sure. I think more recently there was another flyby, and like, it was totally missed. Did you hear about that?
Yeah, it's still happening. It's not really a close. I think you're talking about something else than the one I'm talking about.
Yeah, it wasn't
There's a
Apophis. It
no,
was
no.
like,
There is another flyby happening now where it's more near the Mercury, but it's visible from Earth because of the sun's heat causing the particles that are on the trail of the asteroid to light up and burn. And so it's causing a lot of people to be visible to the naked eye / with binoculars and some smaller telescopes. So there's been a lot of pictures of it on Instagram that people have been seeing.
oh, okay. So no, I'm talking about something that was more recent. It passed by and
Yeah.
nobody noticed.
Mm.
Anyways, I can't find it right now. For some reason, my Google looks different.
Yeah.
Asteroid, recent, no one observed. That's really weird. My Google looks different all of a sudden. Oh, this one, June 15th.
Okay.
Did you hear
I
about this
don't,
one?
honestly, like there's so many news that comes in. Most of it just, I look at it and then I kind of say, not really
Yeah.
important to my work, and it just goes out and.
Yes, but the system, if I understood correctly, there is no system, or the system didn't work, or something like that happened. This was the football size one, so that's like what, 4 acres. Yeah, it just
Well,
whizzed by between the Earth and the Moon, and nothing detected it.
well, that's pretty far and it's small enough. I mean, although like the U.S. Air Force does track a lot of debris from about 10 centimeters up, but that's like ground-based observations. There's definitely they're going to be missing it. But something like that, entering in a trajectory to Earth, it'll burn up in the atmosphere. It's like a no factor that anybody like no one honestly needs to worry about them.
Okay.
Other than for like satellites that are operating high Earth orbit to low Earth orbit, if there's a chance that it will enter, that might be an issue, but most of those are tracked, so that's not a.
So have we tracked everything like in NEO category, near Earth objects?
For the most part, yeah, everything above I believe 10 centimeters is tracked.
But we haven't tracked everything in the asteroid belt.
That's far. No, there's no way. That's pretty far.
So if there's something in the asteroid belt in the Chicxulub category, I think that's how you say it. I have no idea how you say this word. If there's something in the asteroid belt in this Chicxulub category, then we haven't tracked it, you're saying? We have not.
Honestly, I don't know about all the NASA missions they're doing on
Right.
tracking stuff
I,
out
I,
far
I
out.
would I would assume no, because that is pretty far. That's between Mars and Jupiter. And there are no set of like, we'd probably need like tens of thousands of probes, if not more. I don't know what kind of equipment it's going to be, but we're going to need a lot of equipment that
Yeah.
tracks every single big and small rock in that region. And it's going to be a very interesting activity, because something could like, trigger some kind of effect too, because you send something there, trigger something, and next thing you know, you've got like a whole bunch of asteroids flowing in all different directions. So
Yeah. I mean,
I don't know if it's going to be done.
yeah, honestly, there will be industry for, smaller sats to go in and observe these at a closer scale, closer, distance for the purposes of mining asteroids. I know people are talking about, specific, ones that are known to have rare minerals and materials in it that
Right.
can be, very, very valuable.
Right.
So, like we'll need to have probes going out, but it's still a long way from there. We're just building the technology up now to go do this stuff.
Right.
And then we need to have to a point where, it's commercial enough that if we detect it, we can get probes there to
Right.
start mining it in a safer way, not just create dust all over the place and just, float it everywhere.
Right. Yeah, exactly. Yeah, I'm also thinking like, okay, so like we haven't even mapped stuff in our own backyard in terms of the solar system. So things like, I think how you say it, Oumuamua. I can never say this. Chicxulub is hard to pronounce. That is Oumuamua. I think that's how you say it. Wikipedia could do a better job with the pronunciation thing. Sometimes they have a, oh, here it is. Let's take a look at this. Did you hear that?
Yeah.
Oh, that's cool. Oumuamua. Okay. Oumuamua. So yeah, this like we're talking about like a foreign object that comes is like straight from Arthur C. Clarke's what is this? Geez, I just read this last year. Early onset of dementia. Rendezvous with Rama. So I don't know if you've read Rendezvous with Rama. Okay, well, it's a more of it's not exactly Rendezvous with Rama. Rendezvous with Rama, Sir Arthur Clarke hypothesized that there's an actual alien ship that travels through the solar system, and so Earthlings send a probe on board in order to be able to explore it. It's a very interesting story. It's not my favorite from Clarke, but there's some interesting stuff in there. Obviously, this looks like, although there's speculation, but Oumuamua is a large rock. It passed through. It's a cylindrical large rock that entered our solar system and just like kind of went away, and I don't know which direction of the galaxy it's actually headed in.
Well, the problem is like things that like are near us, especially away from the sun, it's dark. We measure and find things based on how it, blocks a light source. That's how we detect planets and stuff far out in the galaxy and stars and stuff, and, like determine various, like their size, their mass, their composition.
Yeah.
By taking various, readings we get and how like known stars are affected by, planets or stuff passing by. But if you look at something like, far out by Pluto or, out in that area,
Sorry.
it's dark.
Yeah.
We don't have, when we're looking at it, it's, we don't have anything to, like affect, change in lights or any kind of, unless it's putting out active radiation or something. It's pretty hard to, notice it. But as it gets closer to our like Earth and the sun and, within the, the inner planet systems, we can detect it a lot, better. But space is huge, it's large amount of space, like unimaginable size. Even the solar system is huge. So like, having telescopes at every little point, trying to, observe at various, if you're observing far away, you're having a different focal length and you're having a different, focus. Like think of a camera, like, you can either be looking at somebody closer or looking at something further, but, it won't cover everything in the middle very well. It's kind of that situation for astronomers to, detect all of them.
Yeah, well, there are specialized cameras that can actually do that, but those are not in the commercial market. These are very kind of, I don't even know who's using these. I think I've seen something. I think President Obama's inauguration, they used one of these cameras and you could actually zoom into every single person's face that was in the shot. That was like hundreds, if not thousands of people.
Well, yeah, I've
a
heard.
very small subset.
Yeah.
I understand the scale we're talking about is like hundreds of thousands of miles, if not more, millions of miles. We're talking about like light distance, like, just going from here till the asteroid belt is probably like I don't know how many minutes. It's not going to be hours, but it's probably going to be in the minutes to get to the asteroid belt. Like to get to Neptune is probably 45 minutes, maybe. I don't know what the distance is in light distance. There's a long way out, man. I appreciate that. So
I mean,
I guess just to summarize,
I know what you're talking about. I've seen them in documentaries, but honestly, like it's pretty advanced, like I'm sure it's pretty
I could be wrong
advanced
on the
military
numbers.
technology.
Oh, gotcha. Okay. Yeah.
And so like, but I mean, I know they use them on drones to, like use one camera, but like, have multiple focus points they can focus on at the same time.
Right.
It's like hundreds of, like camera chips in one chip. So it's, I mean, honestly, I don't really like know too much about cameras other than how a single lens and, how image get captured, but I wouldn't know how like scale it into hundreds of, lenses and are like, processors in one chip.
Yeah.
It's, I'm sure like, there are like amazing electrical engineers and, scientists that understand it a lot better than I do.
Yeah.
And I'd love to work with them, try to build something that can, like look at a section of space and look at various things at the same time. I know that the new ESA satellite is supposed to be able to do that. But then again, I don't really know, like,
Well, I'm
I'm not
thinking.
in the field.
Right. I'm thinking of the utility. Like you'd need a different set of technologies in order to be able to deliver upon whatever the utility is. You don't necessarily need spectral analysis for everything.
Yeah.
So contingent on like what the purpose is. But I guess instead of like sending like, I don't know, like I'm like coming at it from a very uneducated perspective. I guess depends on what kind of infrastructure we build between now and the next 10 years. And, a lot of it is going to depend on that. And like, if we can send hundreds of probes, should we, or should we send one?
We definitely should.
No, I mean, like, I guess the question is if we should send like 100 different probes doing 100 different things, or should we send maybe 10 probes that do 10 things each? And you could like, it's kind of like a cloud-based model kind of thing. The cloud powers a lot of different apps and services. So
yeah,
either do that or you actually have like many different server farms powering many different. That's the kind of question I'm thinking.
Yeah,
but I want to backtrack, like just to understand, like like the way you explained it. So when we were talking about like stuff like exoplanets, you're saying what we do is we measure how the light bends. So like say the sun is here, exoplanet is here, we are like all the way here. So how we measure these things is how the light bends when it hits, because light, every time light hits something, it refracts, right? So we actually we measure the refraction, and that allows us to know a lot of different things in terms of the actual distance of this object from the sun, to like, even like what could be the make and composition within this body contingent on how the light bends. So that's one, like if I understand correctly, you're saying that is one scale. The other scale you're saying is nearby stuff, nearby in like the asteroid, because in the asteroid belt, the light's still shining on them from the sun.
Yeah.
So if we have enough probes, we can actually measure stuff by just like the light bouncing back from these objects. That's another class you're talking about. But stuff that is in the outer solar system is something that is pretty much dark.
Yeah.
Okay.
But I mean, nearby in the the asteroid belt, we can see, like if we have a powerful enough telescope, we can see it as a physical image with our eyes using the telescopes. It's like looking at something nearby with the light versus something miles and miles out where there is no light and trying to detect. There are other ways, there are still residual radiations and little things that are different that we can use to detect them. But once
I was thinking about that
far out that way,
right?
Like we can't use the same kind of technology we used to like detect some like a faraway galaxy or a faraway planet in another star system, because that is what we do. We like measure the light, like refractions. And like these are, for us, it's like tiny, like compared to the scale and the angle we see it at. So we have like specialized instruments that see very, very far and takes these like very precise, like change in light and other radiation energies and like we take the full spectrum and see how, how the wavelength, changes. And using that, we detect, and try to make an educated guess on what it is, how far it is from the planet, and things like that. But when it's in between, our solar system and say like the nearby star, like unless it's literally in line, we can miss it. It can be, slightly off angle, and we can never see it because light isn't like hitting it at strong enough, intensity for us to see it with our current technology.
Interesting. So sorry, what would, like, you're talking about something like Oumuamua or like another body like that, or?
Yeah, something like that. That's, just maybe at the edge of the solar system somewhere.
Yeah, or could anywhere really. Like it
Yeah.
could be anywhere, because like it's coming out completely from like a dark,
Yeah.
because like we're measuring stuff like radiation, and I don't even know like what part of the sky, because it's like an enormous space out there. So like I don't think we have a lot of instruments out there to be able to get like a lot of data from, because like just Hubble is like Hubble was pointing like at a very, it looked like there was nothing there, but that's like just a fraction. Obviously they keep changing the actual focus of where these things are pointing to, but I don't think we are covering like barely enough of the night sky to be able to like, but to bring it down to the essence, like you're saying, it's the light and the radiation, and if something is in effect traveling between two solar systems, we're pretty much in the dark.
Yeah.
So this answers one of my next questions in terms of like gamma ray bursts and like supernovas and stuff like that.
But those are strong energy output.
Like I don't think we're measuring all of the night sky to be able to say convincingly that this is where a supernova is happening.
No, we're not measuring everything. Definitely not yet.
We're measuring something, but we're not like, it's not like it's like distributed set of like projects, I guess, like all over the world measuring things like that, but there's no comprehensive system.
Yeah. I mean, it goes through the same kind of bureaucratic stuff that every organization go through. There's limited sets of instruments and things, and so people would write proposals. They'll be like, hey, I think here's this, I want to study it. They'll write proposals to various organizations, find resources, and eventually a team gets put together, resources get allocated, and time limits get set. Like here's like this many, here's this observatory, or you have access to the Hubble for this long.
Right.
And then you do what you need to do. You take the data, usually gets shared with the community. I mean, nowadays they're pretty open about it. They're not, it used to be they hold the data until they study it, they get the first chance. Nowadays, most researchers are happy to share the data, put it out there while they do the study.
I was going to put the laptop on the charge because it's going to die. Sorry, just give me 1 second.
You're back. I guess not.
Thanks for waiting. You still there?
Yeah. Honestly, like we're like going way outside my field of expertise. Mine is more.
No, it's just to explorate. Like it's I don't get a chance to like talk to anyone else about this. I did read this. It was going slightly off topic here, but there's actual peer-based review backed research that states that we have gone through like 6 major extinction cycles on this planet alone. So, or is it 5 or 6? I forget.
I have no idea.
I think it's 5 in total. Yeah. There's some new research that suggests that we're undergoing like a 6th extinction cycle, and these happen over a time scale. It's not really 5-10 years because we're talking about the die-off of entire species. But there's another research that cites that these are like the 5 major extinction cycles. I think there are 5 in total so far. But there have been like many other extinction cycles that are not as, well, they're not the major extinction cycles. But the research paper posits that, I can dig it up, like not right now, but maybe like after this call.
Yeah, I believe you. Yeah.
Half of all of the major extinction cycles are due to a cosmic event, with gamma ray bursts cited as the probable cause of wiping out 50, like in this major extinction category. Half of them, so like 2.5 in this case, or 3 extinction events were caused by gamma ray bursts. Now,
I did not know that.
we are talking about life evolving for billions of years. So,
Yeah.
the last one we have recorded evidence for that at Chicxulub, but prior to that, there may have been many cycles of life that may have been wiped out instantaneously, and life would pretty much have to reboot from whatever stage it was pushed back to. And that depends on like the stage of the evolution of life, at least on this planet.
Yeah.
So this is something I want to like, but I guess like the time scale we're talking, like, like maybe that's why there isn't any, I guess, political will for like a lot of projects like this, because if something is going to get impacted, I guess 200 years from now or 50 years from now, even, then the political cycles are only
Well,
4 years.
50 years would, light a fire under a lot of governments. 200 years, it'll be in the back thought. But
Yeah,
this is probably going to be in like, 5, 10,000, 50,000 year range.
we don't know is the
You
answer,
know,
because we don't know the rate of actual, like,
true,
cosmic events that have the potential of causing like significant disruption. We just don't know.
true.
I mean, I don't even know if we can predict when the next major solar flare is going to happen. That's going to be pointed right at us. So, we're dealing with a lot of. So, anyways, coming back to Apophis. So, you were saying that we should create a cluster of CubeSats to not just track this object, but do what else? Like land on it, take some samples, redirect the trajectory of this to
Yeah, I mean, land on it, get samples, maybe try to return some. Well, not with the CubeSat, obviously. There's no way we're going to, it's too massive. But, it would be nice for a nice planned mission with, multiple governments funding it to come together to try. Not like we're not going to do it too much, maybe like a couple of degrees off, just to prove that we can, as a potential proof for, we're going to be able to, take a huge asteroid, put it into orbit around either Mars or the moon or some system, and be able to slowly mine it to make the resources to make long-term, space, consumption and livability possible without having to, constantly deplete the Earth's resources.
Yeah, no, well, makes total sense to me. Like, I mean, it seems even if you could build like something like a space elevator and send mounds and mounds of stuff in orbit super cheap, I don't think you should, because there are like a lot of the things we may want to send from Earth are already in orbit. Well, with the asteroid belt, with the minerals, and like we don't know what's there because we haven't classified each one of these objects, so we have no idea of the actual composition. That's one. Then there's all the in situ resources, which is another conversation, not exactly on topic, but I totally hear you. Like, it doesn't make sense to send stuff from Earth into orbit and beyond. Just like mine whatever you can in there, and yeah, makes.
Yeah, I mean, we build, I mean, like, as that's how things evolve. If we keep thinking of everything going from Earth out, we're, fixed into just on the mentality purpose. We're fixed on, what's available on Earth we can use that's, feasible for a purpose. Now, if we have, that with the opening up of, space resources and possibility of, using things that are available in space to build, now it's a different mentality of, figuring out and being more resources for what's available. And like, say, like, something like gold that is very valuable on Earth, that, most of the gold came from the outer space. So if we can find like a huge asteroid with a giant, like deposit of gold, that just changes, hugely. That, like a lot of, the UVA suits
Sorry, who?
use spacesuits
Yeah, what
use
about them?
gold shielding to protect the people inside it.
Oh,
It's
okay.
expensive. If we can find gold out in space, now you can use that to mass produce suits. more people in space. So it's, it's like now we're thinking of like, especially me too, like, as a business person, I have to think about things in a way that, is this mission going to be fundable? Am I going to go broke? There's hundreds and thousands of companies that have gone broke trying to do this huge mission with, no resources. So like we have to figure out if resources are possible. That's a huge limitation. If we can find resources and like outside of Earth, that's, a huge benefit to various missions, and it enhances the capabilities that that is possible.
Sorry, everyone's deciding to I've got this app I use, this scheduled random call. So I got one scheduled call and one random call. What are the odds of that happening when you're doing a live or recorded session?
No, it's fine. I mean, we've been talking for about 45 minutes now. I mean, honestly, I do have a time crunch. I've been working on stuff. And
Yeah,
I'm
so I
trying
think
to, like,
I'm going to run out of the, no, I wasn't do that. Like, but yeah, I understand you've got a time crunch, but yeah, no, like it's like, I think timing is a big factor. I was going to just backtrack quickly to the article you shared with me about Apophis. So I haven't read the article, like I said, but like I see the mention of a couple of nation states. And I like it looks like a lot of the, like, outside of the G20 group of countries, there are some upcoming kind of like, at least from the perspective, like how governments can come in and fund some of these bigger projects. The government of UAE seems to be doing some good work. They have a Mars mission. We're talking about Apophis here, so I don't know what the angle there is. And obviously there's definitely a flurry of activity there with respect to how they want to, like, tie in with what's going on with the enablement of this new frontier. So yeah, that really, I'm thinking like from a kind of just a geopolitical angle, that would be really good for collaboration, and the prospect of peace coming as, I guess, I don't want to classify it as a byproduct, but historically there has been a lot of wars in the Middle Eastern region, with obviously the Gulf Wars and what's going on in Yemen right now, Syria. So I think this would be a pretty, it would be kind of like a possible direction in terms of what is possible, and not just in the region but all over the world. Like if large groups and teams actually come together and collaborate on like a really big project, I think that would be really good for the global construct.
That is definitely true. Like the possibilities are endless. It is what we make of what's given to us that is the limitation.
Well, I guess we place these limitations on ourselves because of mindset mostly. This is the off-topic thing. I meet a lot of, like, I just happen to like meet individuals, and I think my Zoom is going to end soon, but I like, sometimes I'm just kind of like amazed with the limitations some individuals place on themselves. It just comes down to stories in the minds, but this, again, like I said, this is another conversation.
Yep.
Okay, well, did you want to share something else before we go?
No, I think like we shared more than enough for one meeting.
So I'd like to continue
Just save
this.
stuff for the future.
Yeah, so like let's talk more about what's going on your side with the CubeSat angle next time we meet. And then you can share an update about team funding if you're looking for funding, and when do you look to like move ahead with, like you mentioned in the first call, you're already moving ahead with it, but it would be good to get a glimpse of or like get an update on like the actual customer discovery process and what's next.
Yeah. Well, you're kind of like, like trying to look at it from a tech angle where like, everything is like, compressed in a, like an accelerated phase. I'm looking at, my like Iwin space as a long-term project. We're slowly building technology and customers and, an ecosystem for a long period of time. So like I try to plan for missions that are, far out, like, but while still trying to, meet revenue requirements to keep it going. So it's not, you know, like set in stone. There's so many things changing constantly. People coming in and going. People get interested and they lose interest. And so I just, you know, manage things. It's not like set in stone. So it's very hard to like talk about it because a lot of things are constantly changing.
Well, I would question that. I like based on what you've shared with me with like we both appreciate like the enablement of the platform itself with like two major companies, at least three major, ULA, SpaceX, and Blue Origin playing the driving force. They are the driving force behind this from a like, North American perspective.
Yeah.
But you also have like Rocket Labs, I believe, something you shared with me. So you
Yeah.
know, there's
Rocket
other
Labs.
companies. There's other companies that are like jumping into the mix here.
Yeah. There's actually two startups within the last couple of years just in New York City on rocket development.
Oh wow, New
Yeah.
York.
There's a whole bunch out in Florida, whole bunch out in the Midwest, Middle East, India, Europe, and like England, France. So there's like startups popping up everywhere. The thing is, these are, you know, ideas with little funding, are like, you know, people bootstrapping, or some with large funding, but even those people are trying to figure out what they're going to do with stuff. So it's a very fluid situation, especially with COVID now. Nobody knows what they're gonna do. It's, you know,
Yeah, well, the COVID situation is gonna like depends on what happens next. Like you know, there's successive cycles, and a lot of it comes down to how humans respond to how you know the whole COVID situation is materializing or dematerializing. If it's dematerializing, we kind of go back to, I guess, the status quo, which I don't think is a good thing, but that's another very different conversation. If it is a change, then we adapt and kind of go from there. But I think if anything, the COVID situation should like at least make us think about all the stresses on the ecology and the ecosystems and the way we actually get our meat and you know other products and how we got to think about all these factors in the supply chain. But I guess to come back to this topic, what I'm thinking though is, Peter Thiel, how can you achieve your 10-year plan in the next 6 months? You know, it's a really solid quote, and I think if you approach things from that perspective, then it's like a different level of good pressure on to deliver whatever you're working on. So something to think about, not necessarily to go off on you know on a completely different kind of tangent. But
yeah.
I learned so much talking to you because like the things you share with me is like something that would take me like tens of hours or Googling. I don't even know if I could do
Well,
that.
it takes me tens of hours of Googling, so
So
it's just like trust me, like I read so much, I lose like 95+% of the things. I wish I can just retain in my head. Like it would be very useful. But you know, just knowing that there's this out there I can look up later helps with, you know, planning things and trying to figure things out.
Creon Levitt has this talk on the internet. This is off topic, but he talks about the Memex Chrome. I think it's a Chrome browser or just like a web browser, like an extension. Sorry, it's called Memex. So you can it actually records each one of the sites you visited. So you can just type the description of what you're looking for. It automatically describes it for you. So you don't have to remember the name per se. You can just type
MEX, you said?
like memory, but
Okay.
Memex. Memex.
Okay.
There was an actual invention called Memex, I think, going back to Vannevar Bush. So I don't know if it's like it's in like you know it has something to do with this, but yeah, it's called M for mango, Memex.
Okay, yeah, I'll look into it.
Yeah, I think what you like validating. I mean, yeah, you're right. I'm taking a startup approach to this, but I think that would be a very like I'm very open to criticism by yourself and others on this, whoever may be watching this afterwards. But I think that would really I think that's a good approach. And I think the other thing that we talk about in startups is timing. So you got to time this right. At least going back to Gretzky, you know, you should be ready when the puck is where you want it to be, and then luck is going to meet preparation. Sorry, opportunity is going to meet preparation. So I don't see any reason why taking a more of a functional or structured approach to validating this may not. I could only see it yielding good dividends now in the future. and like, you know, you will be prepared. Like, I don't know how the resource-based economy is going to look like in the future. And we didn't explore like a lot of other subtopics that are come about it. When you're talking about gold, I was thinking, what if you do find something with it's got like a ton of gold in it, right?
Yeah.
And then the market for gold just kind of, there's some static here. The market for gold
Yeah.
just plummets overnight if you do
Yeah.
find one asteroid. So we have to be mindful of unintended consequences like that. But overall, I think it's going to be pretty much inevitable to colonize. Again, this is a loaded word. So maybe like terraform other habitats, and you know, I think starting with the asteroid belt and well, near Earth objects, it sounds like a pretty. It would be really awesome to like pick like Chris Luecki's brain on this topic, like, you know, like what stage is consensus at, or planetary resources at, and like what's next for them, and you know, where they're thinking of going in the next 5 to 6 years.
You should try and reach out and see if you can, you know, schedule a call with them. I'd happily join in. I'd love to, you know.
I don't know if
more.
Chris Luecki would want to talk to me, at least.
Well, I mean, honestly, we definitely would have to, you know, like learn more about the topics, so we can, you know, talk, you know, about these things at the kind of knowledge level, you know, they operate at. You know, they're constantly working on these things, a lot more than I am. So.
Yeah, I hear you. Like, we'd probably have spent a couple of 10, 20 hours just to prepare for like a 1 hour call. Easy.
Yeah.
Okay, we'll keep that as let's keep that as a park that as a thought, and it would be pretty phenomenal to talk to Luecki. Like, I'm like just getting him intimidated at the thought of just reaching out to him, because that's like I don't know if I was talking to you, but I really believe Luecki is. I know you got to go, so like we'll keep it for. But I think Luecki is definitely one of the like most hardworking / intelligent individuals. Intelligence comes from like putting in consistent effort. So his career seems like is just being like boom, 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 like consistent effort through and through. So I think he's probably in like, you know, the 20 most smartest individuals alive right now, I think. All right, man. You got to go. So good chatting with you again, and I'll talk to you next week. Unless you have anything else to add.
All right. See you later. Talk to you next week.
All right.
No, that's it.
Okay.
Bye.
Bye now. Thanks.